And that's how they ended up with a chatbot that thought everyone wanted pizza even when they were asking about cloud storage pricing.
Okay, that's spectacularly bad. Pizza for cloud storage? How does that even happen?
It's the classic case of stateless AI agents gone wild. Imagine a support chatbot, right? Each turn is treated as a completely fresh interaction. It forgets everything you said 5 seconds ago. It's like talking to someone with extreme short-term memory loss.
So every question is a brand new conversation. I see the problem. That's not just annoying, it's completely useless for any complex interaction. Think about booking a flight. You need to remember the origin, destination, dates.
Exactly. And that's where LangGraph comes in. It's a framework designed to build stateful, multi-step AI workflows. It lets you create AI agents that remember, reason, and adapt. No more pizza-obsessed chatbots.
Okay, stateful is the key word here, but what does that actually mean in practice? What's the alternative, and why is everyone suddenly talking about graphs?
All right, so think of a traditional AI agent as a single node in a network. It takes an input, processes it, and spits out an output. Done. Stateless. The alternative before LangGraph was basically duct taping a bunch of these nodes together with a lot of custom code to try and manage the flow in the memory. It was messy, error-prone, and hard to scale.
Sounds like a nightmare to debug. So LangGraph is trying to provide a more structured way to manage that complexity?
Precisely. Imagine a directed graph where each node represents a different action or decision point for your AI agent. One node might be extract user intent. Another might be retrieve relevant information from a database. And another might be generate a response. The edges of the graph define the possible transitions between these nodes. And here's the crazy part. The graph itself holds the state of the conversation.
Okay, I'm starting to see it. So instead of the state living in some external, hand-rolled system, it's baked into the graph structure itself. What does this state actually look like? Is it just a big blob of text?
It can be whatever you define it to be. That's the beauty of it. It could be a simple dictionary of key value pairs, or a more complex data structure, or even a custom class. The key is that it's accessible to all the nodes in the graph, allowing them to share information and make informed decisions. Think of it like a shared brain for your AI agent.
Okay, shared brain. I like that analogy. So we've got nodes, edges, and state. Let's talk about how this translates into real-world applications. Give me an example.
Let's say you're building a customer support bot for Netflix. A user might start by saying, "I'm having trouble streaming Stranger Things." The first node in your LangGraph workflow might be identify the user's intent, which in this case is streaming issue. The state would then be updated to reflect this intent.
Right, and then what?
The next node might be retrieve user account information. This node would access the Netflix database, fetch the user subscription details, device information, and viewing history, and add it to the state. Now the agent knows who the user is and what they've been watching.
Okay, that makes sense. So the state is growing with each step. Then presumably a node would try to diagnose the problem.
Exactly. A diagnosed streaming issue node would analyze the information in the state and try to identify the root cause of the problem. It might check the user's internet connection, the Netflix service status, or the device's compatibility. Based on the diagnosis, the agent can then take appropriate action, such as suggesting troubleshooting steps or escalating the issue to a human agent.
That's a much more intelligent interaction than the pizza chatbot. But what happens when things go wrong? How does LangGraph handle errors or unexpected input?
That's where the graph structure really shines. You can define different paths for different scenarios. For example, if the diagnosed streaming issue node fails to identify the problem, you can have an edge that leads to a human escalation node. This node would then hand off the conversation to a human support agent, along with all the information that's been gathered in the state.
So it's not just about remembering, it's about intelligent routing based on the state. That's powerful. What about something more complex than customer support? Could you use LangGraph for, say, building a personalized recommendation engine?
Absolutely. Think about how Netflix, or even better, Spotify, recommends music. They don't just look at what you've listened to in the last week. They consider your entire listening history, your preferred genres, your mood, the time of day, and even the weather.
Okay, the weather might be a bit much, but I get your point.
With LangGraph, you could build a recommendation engine where each node represents a different factor that influences your music taste. One node might analyze your listening history, another might analyze your social media activity, and another might analyze your current mood based on your recent activity. All of this information would be aggregated into the state, and then a final node would generate a personalized playlist.
So the state becomes a rich profile of the user's preferences. But doesn't that raise some serious privacy concerns? How do you ensure that this data is being used responsibly?
That's a crucial point, Shrija. Privacy and security need to be built into the design from the very beginning. You need to be transparent with users about how their data is being used, and you need to give them control over their data. LangGraph itself doesn't solve the privacy problem, but it provides a framework for building more responsible AI agents. You can, for example, add a node that anonymizes the data before it's used for recommendation.
Okay, so responsible implementation is key. What's another real-world example where LangGraph could be a game changer?
Consider a self-driving car. It's constantly making decisions based on its environment. It needs to remember its previous actions, predict the behavior of other drivers, and adapt to changing road conditions. A LangGraph workflow could be used to manage all of these complex tasks.
How so? That sounds incredibly complex.
Imagine nodes for detecting objects, predicting trajectories, planning routes, and controlling the vehicle. The state would include information about the car's location, speed, direction, and the surrounding environment. The graph would then define the rules for how the car should respond to different situations. For example, if the detecting objects node identifies a pedestrian crossing the street, the graph would trigger a braking node to slow down the car.
Okay, I see how the statefulness is critical there. You can't just react to the present moment, you need to anticipate what's going to happen next. Otherwise, you're going to have a lot of accidents.
Exactly. And here's where it gets interesting. Most engineers, when they first approach LangGraph, they try to build the perfect graph up front. They try to anticipate every possible scenario and hard-code it into the graph structure. But that's the wrong approach.
Why is that? It sounds like you should be planning for every eventuality.
Because the real world is messy and unpredictable, you can't possibly anticipate every scenario. The key is to build a graph that's flexible and adaptable. You need to design it so that it can learn from its mistakes and adjust its behavior over time. Think of it less like building a static blueprint and more like cultivating a living organism.
So it's about creating a framework for learning, not a rigid set of rules. How do you actually do that in practice?
You can use techniques like reinforcement learning to train the graph to make better decisions. You can also use human feedback to correct its mistakes. The goal is to create a graph that's constantly evolving and improving. It's not about designing the perfect agent, but designing an agent that can become perfect.
That's a subtle but crucial distinction. So what should a software engineer do differently after listening to this? What are the practical takeaways?
First, stop building stateless AI agents. Seriously, think about whether your application could benefit from statefulness. If you're building anything more complex than a simple chatbot, the answer is probably yes.
Okay, ditch the statelessness. What else?
Second, embrace the graph mindset. Think about how you can represent your AI workflow as a network of interconnected nodes. This will help you to break down complex tasks into smaller, more manageable pieces.
And finally?
Third, don't try to build the perfect graph up front. Start with a simple graph and iterate on it over time. Use data and feedback to guide your development. Remember, it's about building a living organism, not a static blueprint. Think grow the graph, not build the graph.
Grow the graph. I like that. It's a good reminder that AI development is an ongoing process, not a one-time event.
Exactly. And if you're still building stateless agents, remember the pizza chatbot. Nobody wants that.